Hi guys, in today's lesson, I'll be teaching us shells, energy level, and electronic configuration. So I want you guys to stay to the end of this lesson. If this is your first time coming across my video, I want you to subscribe to my YouTube channel at Divine Online Chemistry Tutorials. So let's commence with today's lesson. In one of my previous videos, I talked about atomic structure and also isotopy. These two videos are on my YouTube channel. If you have not watched these two videos, I want you guys to watch these two videos so that you get the whole idea about atomic structure and isotopy. So let's commence with today's lesson. But in that my previous video on atomic structure, I talked about the structure of an atom, and I said that an atom is made up of two major parts, which include the nucleus and the shell. So I said an atom is made up of two major parts, the nucleus and the shell. So these two parts and the shells, these two parts makes up the atom of an element. And I said that the nucleus is further made up of two parts, the proton and what the neutron. So the proton and the neutron makes up the nucleus of what? Of an atom. And please also take note that the nucleus of an atom is the heaviest part of an atom. So please take note that the nucleus of an atom is the heaviest. The heaviest part of an atom, and the nucleus of an atom is situated at the center of the atom. So please take note that the nucleus is situated at where? At the center of the atom. So please take note that the nucleus is situated at the center of the atom, whereby the shells spin around the nucleus of an atom in orbit form. So please take note that the shells spin around what? The nucleus of an atom in orbit form. And also please take note that electrons are found where? On the spinning shells. So electrons, they are found on the spinning shells. So also please take note of this also. So having said all this, in today's lesson, our major focus will be what? On the shells and electrons. So our major focus will be on the shells and electrons. Now please take note that in chemistry, shells are usually being represented by letters written in alphabetical form. So please take note that in chemistry, shells are usually being represented by what? By letters written in alphabetical form, and they include the K shell, the L shell, the M shell, the N shell, the O shell, the P shell, and the Q shell. So these are the various shells that we have in chemistry. And please take note that they can be represented diagrammatically like this. They can be represented diagrammatically like this, where we have the nucleus. And please take note that the K shell is the first shell and the one closer to the nucleus of an atom. So please take note of that. So we have the K shell, which is supposed to be the first shell. So the K shell, we have the next one, which is the L. We have the next one, which is the M. We have the next one, which is the N. We have the next one, which is the O. We have the next one, which is the P. We have the next one, which is the Q. So there are seven. There are seven in number. 1, 2, 3, 4, 5, 6, 7. Yeah, there are seven in number. So this is the way you represent what? This is the way you represent it diagrammatically. Whereby the nucleus is situated at the center. Whereby the shells, they are spinning around the nucleus in orbit. So please take note of this. So the first shell here The first share here is the what? Is the K share. The K share. The next one, the L share. The M share. The N share. The O share. The P share. And the Q share. So this is the way we represent shares. This is what the diagram form. And of course, this is the nucleus, which is situated at the center of the share. So this is the nucleus. This is the nucleus. So guys, please take note of this. So this is the way we represent them diagrammatically. So from here, we'll be moving straight to energy level of a share. Please take note that energy level refers to the minimum amount of energy that each share can carry, or each share possesses. Okay, so guys, take note that energy level of a share refers to the minimum amount of energy that each share possesses. So take note of this. Now, of course, each share do not possess equal number of Please take note that all the shares do not possess equal number of energy level. Because there are some shares that are closer to the nucleus of the atom, while there are some shares that are farther away from the nucleus of an atom. So explaining all this now therefore means that each share does not equal number of energy level. Now let me explain this energy level using this diagram. Now if you look at it very well, the K share is the first share and the one closer to the nucleus of an atom. Now since the K share is the first share and the one closer to the nucleus of the atom, now it therefore means that the distance between the nucleus of the atom and the K share is short, which means the energy level of the K share is low or is small. So compared to the Q share, which is the atomic share, the energy level of the Q share is high, because the Q share is farther away from the nucleus of the atom. There's a distance between the nucleus of the atom and the Q share compared to the nucleus of the atom and the K share, which happens to be the first share. So as the share is increasing, their energy level is also increasing. So as the share is increasing from the K share to the L share to the M to the N to the O to the P and to the Q share, their energy level is also increasing. So guys, please take note of this, that each share do not have equal number of energy level due to the distance between the nucleus to the share. So please take note of this. So this is all about energy level. I hope you guys understand what I just explained right now. If you don't understand, please drop what you don't understand at the comment section. Please, if you also find this class very interesting, please, I want you to subscribe to my YouTube channel at Divine Online Chemistry Tutorials. Also do to like my video, share to your friends, and also comment. Please, let's continue with the class. So from here, we'll be moving straight to the maximum number of electrons that each share can carry. Please also take note that shares cannot carry equal number of electrons. Please take note that shares cannot carry equal number of electrons. Now, how can we now determine the number of electrons that each of these shares can carry? Now, the maximum number of electrons can be determined by using this formula. 2n raised to power 2. So please take note that with this formula, which is 2n raised to power 2, we can determine the maximum number of electrons that each of these shares can carry. Now please take note that in n, this more than n in this formula means or stands for principal quantum number. Principal quantum number. So please take note that n in the formula stands for principal quantum number. So n equal to principal quantum number. Please take note that this n, which is principal quantum number, has value for each of the shares. Now let's let's talk about the values of n for each of what of these shares. Now let's start with the k share, which happens to be what the first share. Now if you look at it very well from this diagram, you see that the k share is the first share and the one closer to the what to the nucleus of what of an atom. Now since the k share is the first share and the one closer to the nucleus of an atom, it therefore means that n, which is the principal quantum number for the k share, is what is 1. So therefore n for the k share is equal to what? It's equal to 1. Reason because n, really because k share, the k share is what is the first share and the one closer to what the nucleus of an atom. Now what about the L share? N for the L share is what is 2. The reason why n for the L share is 2 because the L share is what is the second share and the one closer to what to the first share, which happen to be what the k share. Now since L is the second share and the one closer to what to the k share, it therefore means that n, which is our principal quantum number, n is equal to what? Is equal to 2. Same thing goes to the rest, n equal to 3 because m is what is the third share. Then same thing to this, n equal to what? 4 because n is the fourth share. Same to this, n equals to what? 5 because what? O is the fifth share. Same thing to this, n equal to 6 because p is what is the sixth share, and same thing as this, n equal to what? 7 because q is what is the seventh share. You can see it very well from what from this diagram. So I haven't brought out this. Now let's start using this formula to prove the maximum number of electrons that each of these shares can carry. So let's prove it. So the k share using the formula 2n raised to power 2, we have 2 times where n for the k share is 1 raised to power 2 equal to what? 2 times. Now 1 raised to power 2 is sitting and say 1 times 1, and 1 times 1 is still what? 1. So equals to what? 2 times 1 is what? 2 electrons. 2 electrons. So you can see that the k share can carry what? Maximum number of what? Of 2 electrons, which means that the k share cannot carry any electron more than what? More than 2 electrons. So any element that have electron more than 2 electrons and you want to represent it using share method, please take note that the k share can only carry maximum of 2 electrons, which means the other electrons will fall in the other shares closer to what? To the k share. Now what about the L share? Now the L share, let's calculate for the L share. The L share, use the formula 2n raised to power 2. We have 2 times. Now n for the L share is what? 2 raised to power 2. Which they will now have 2 times. 2 raised to power 2 since I say 2 times 2. Now 2 times 2 is what? Is 4. Which equals to 4 times 2 is what? Is 8 electrons. 8 electrons. So you can see that the L share can carry maximum number of what? Of 8 electrons. Now what about the M share? Now the M share is what? The third share. The M share is what? The third share. Use the formula 2n raised to power 2. We have 2 times where n for the M share was 3. 3 raised to power 2 equal to what? 2 times 3 raised to power 2, since I say 3 times 3. And 3 times 3 is what? Is 9. Equal to, now 9 times 2 is what? 18. 9 times 2 is what? 18 electrons. So 18 electrons. 18 electrons. Now, what about was the fourth share? The fourth share was the N share. So let's calculate the N share. Use the formula 2n raised to power 2. We have what? 2 times. Now n for what? For the N share is what? Is 4. 4 raised to power 2 equal to what? 2 times. Now 4 raised to power 2, since I say 4 times 4. And now 4 times 4 is what? 16. Equal to, now 2 times 16 is what? 32 electrons. 32 electrons. So the N share can carry a maximum number of what? Of 32 electrons. So I'm going to be stopping here. I'm going to be stopping here for the what? For the N share, for the first 20 elements. You can also prove this O share, the P share, and the Q share, and also drop it at the comment section. So I'm going to be stopping here. Now, if you look at it very well, you see that using the formula, the K share can carry maximum of 2 electrons, the L share maximum of 8 electrons, the M share maximum of 18 electrons, and the end shell maximum of what? 32 electrons as proposed by what? By the formulas. So you can see it. Now from here, let's now use elements to represent what? This shell method. Let's use element to represent this shell method. Hydrogen is what? Is the first element in the periodic table. So I'm going to start with what? With hydrogen. Hydrogen. Now, please take note that the atomic number for hydrogen is what? Is 1. And what is atomic number? Atomic number refers to the number of protons in one atom of an element. And please take note that atomic number is also known as what? As proton number. Please take note of that. And if the atomic number of hydrogen is 1, it also means that proton number is what? Is also 1. And please also take note that for a neutral atom, the number of protons is equal to the number of electrons. Now, if the number of protons of hydrogen is 1, it also means that the number of electrons of hydrogen is what? Is also 1, which means that hydrogen has what? 1 electron. Now, if you want to represent this using shell method, we are going to represent it like this. This is the shell. This is the nucleus, I mean. So, this is the shell. You must start with the first shell, which is the K shell. Now, with electrons. Now, hydrogen has what? 1 electron. So, you are going to represent it like this. So this is the way to represent it. What? This is what? The shell method. So this is the way to what? To represent it. You must always start with the first shell, which is the K shell. You must always start what? With the first shell, which happens to be what? The K shell, which have what? The lowest energy level. So you must always start with the first shell, the K shell. So this is the way to what? To represent it. The shell, the nucleus, and the 1 electrons spinning as the shell. This is the way to what? To represent it. Now let's move to what? To the next element in the periodic table, which happens to be what? Helium. So let's talk about what? Helium. Helium. He. Atomic number 2. So atomic number for helium is what? Is 2, which means that helium has 2 electrons. Now if you want to represent it with using shell method, it's same process. Same process. Now helium has what? 2 electrons. So I'm going to represent it like this. 2 what? Electrons. So you can see the 2 electrons at the what? At the spinning shell, spinning around what? The nucleus of an atom. Please take note of this. If the shell you are working with, if electrons are not filled, if the maximum amount of electrons that is supposed to feed the shell you are working on is not yet filled up, please, you don't have any right to move straight to the next shell. The shell you are working on must be filled with the maximum amount of electrons that is required for that shell before you move on to the next shell. Now, the K shell is the first shell, and the K shell can only carry maximum of 2 electrons. That's the reason why I'm still working with what? With the K shell. And now helium has what? Only 2 electrons. So you fill it with what? On the K shell, which happens to be what? The first shell. So this is the way we represent it. Now, what about what the next element in the periodic table, which was the lithium. So we are going to solve for the lithium. So just stay to the end of the class. We're going to solve for the lithium. Lithium, symbol is what? Li. Atomic number is what? 3. Now it's not becoming complicated now. Now let's watch for what? For the lithium. Now the lithium has 3 what? Electrons. Now this is what to represent it. You will always start with what? With the first shell. You must always start with what? With the first shell. And this is the nucleus. This is the nucleus. The first shell is the K shell. Don't forget that lithium has what? 3 electrons. So you start with the first shell, which is supposed to be what? The K shell. The K shell can carry what? Maximum number of what? Of 2 electrons. If you look at it very well now, this is not complete because lithium has 3 electrons. And you must always start with the K shell, which is the first shell. Now the K shell can only carry maximum number of what? Of 2 electrons. And now lithium has 3 electrons. What are we now going to do to impute the 3rd electron to be among what? These 2 electrons? The next thing to do is what? Is to introduce the next shell, which is the L shell, following what? The K shell. So we now put what? The 3rd electron in the L shell. So if you look at it very well now, the 2 inner electrons as the K shell plus this 1 electron as the L shell now makes it what? 3 electrons. So this is the way we represent it. And please take note that the K shell can carry maximum of 2 electrons. The L can carry maximum of number of what? Of 8 electrons. Not until this L shell is what? Is filled up, you can't move to what? To the next shell. They must be filled with the maximum number of electrons that they can carry before you move to what? To the next shell. So this is how you represent it for what? For the first 20 element. So I'm going to be stopping here for the lithium aspect. Now let's move to what to the last part of today's lesson, which happens to what electronic configuration. Now let me show you guys another method for representing what the maximum number of electrons that each shell can carry. If you don't want to use this diagram, you can also use numbers by differentiating the numbers with what? With comma. So that's what we know as what electronic configuration. So now let's start with what? With hydrogen. Now hydrogen has what? Hydrogen has what? One electron. Now if you want to use number to represent it under electronic configuration, you just write it like this. The symbol for hydrogen is what? Is 1. The atomic number is here. Now you write what? 1 here for what? For the hydrogen. For the hydrogen, okay, remove the atomic number. For the hydrogen, you write 1 here. Now what about for the helium? For the helium, you write what? 2 here. Now this number are the number of what? Electrons. For what? For the element. For helium is what? 2. What about lithium? Lithium. Now if you look at it very well, the first shell, when the case shell can carry maximum number of what? Of 2 electrons. So you put 2 here, comma, because lithium has what? 3 electrons. And the first shell can only carry what? 2 electrons. So you put what? 2, 1. How many electrons are remaining? 1. So now about 2, 1. Are you seeing it now? So this is another way you get to represent it. If you don't want to use the diagram method, you can also use this method. 2, 1. You must always put comma to separate the electrons from each other. Because if there's no comma here, I will assume that this is 21. So once you put comma, it means that there's 2 here, then 1 here. So this is another way you get to represent it. Now the next element in the periodic table after lithium is what? Beryllium. Which have atomic number of 4, which means that beryllium has what? 4 electrons. So if you want to represent this using what? Electronic configuration until what? 2, because the first shell, which is the K shell, can carry maximum number of what? Of 2 electrons. So you move to the next shell, which is 2, what? 2. I see it now. So using numbers, you can also what? Represent what? The maximum number of electrons that each shell can carry. If you don't use what? The shell method, which is the diagram. So with this, we have come what? To the end of today's lesson. I hope you guys understood all what I've taught here today. So thank you guys for staying to the end of today's class. Please don't forget what to subscribe to my YouTube channel at Divine Online Chemistry Tutorial. If this is your first time coming across my video, and don't forget to like my video, to comment, and also to share to your friends and your loved ones. Bye, and see you in my next class.